for watching this AI Weekly Update from Henry AI Labs. This has been a really exciting week in AI with things like OpenAI's multi-agent hide-and-seek agents, learning to use tools with reinforcement learning, Facebook's advances in self-supervised learning with things like wave-to-vec for speech recognition, and then forming new datasets for question answering. Also, there's a lot of new interesting research around the Interspeech 2019 conference and many more things covered in this AI Weekly Update video. Also unique to this week's video is going to be timestamps linked in the description that will show the different blog posts and research covered throughout the video. Thanks for watching, and please subscribe to Henry AI Labs for more deep learning and artificial intelligence videos. The headline story in this week's AI Research Weekly Update video is the success of reinforcement learning agents in OpenAI's multi-agent hide-and-seek environment. So they show their environment in this video where you can see that the red agent is the seeking agent and the blue agents are the hiding agents. So it's interesting in this environment. They have access to these blocks that they can use to pick up, move around, and lock in place to create enclosements like this where the seeking agent can't get in to view the hiding agents. And then also the seeking agents have access to this ramp which they can use to place and then run over it to get into the hiding agents enclosements like this. And the hiding agents learn behaviors as well, like grabbing the ramp and then bringing it into the enclosed space, so the seeking agents have no way to possibly get into their little structure that they've built for themselves. And they get even better at this, learning how to coordinate between the two and be cooperative, which is a really interesting thing with this multi-agent dynamic. So the way that the multi-agent hide-and-seek environment is constructed is the agents can move themselves in the X and Y directions, they can see objects in their line of sight, and they can also have this LiDAR-like sensor which gives them this 360-degree sense of objects and agents and walls around them. They can grab and move the objects, and then they can lock the objects in place. So really interestingly is the way that the agents are able to learn to use the objects, even with this really sparse reward of +1 if they're hidden and -1 if they're seen by a seeker, as well as this sparse reward in the seeker as well. So they find these distinct emergent behaviors that happen as they simulate in these different environments. So starting off in the simple environment, the agents first just move around randomly. Given that they're initialized randomly, they have no sense of the world, the objects, or how to make any sense of their state sensors like the LiDAR sensor or the output ability to move themselves. So eventually the seekers learn to chase the hiders, and this doesn't happen until 2.7 million episodes, which is something that's raised a lot of criticism from people in the Twitter sphere reacting to this study, as they say, oh, I can't believe it takes them 14.5 million episodes to learn to do this. But then after this, they learn, after 8.62 million simulations, they learn to go grab the blocks and then block the doors with them. Then the seeking agents, after 14.5 million simulations, learn to go grab this ramp and use it to jump into the enclosed space and find the hiders. Then the hiders smartly learn to grab the ramp and hide it in there with them, so the seeking agents have no way of getting into the ramp, to the enclosement, and then they learn to coordinate just to more efficiently go and grab the ramp. Following the success in the simple environment, the researchers from OpenAI scale up the environment to more complex situations with 1 to 3 hiders, 1 to 3 seekers, 3 to 9 blocks, and say 2 ramps, and then more randomization with the rooms and doors, like the walls in the initial environment. So they find the same sequence of emergent behaviors, which is really interesting. So first the agents move around randomly, then after 22 million episodes, something that raises a lot of criticism from the algorithm is how long it takes for it to learn things, but besides the point. After 22 million episodes, the seekers learn to chase the hiders. Then after 88 million episodes, generally the agents learn to construct shelters. And then following this sequence of behavior where the seekers then learn to use the ramps to get into the enclosements that the hiders might construct for themselves. And then the hiders learn to go and grab the ramps and bring them into their enclosement space. And then also interesting is this behavior of box surfing, where similar to this paper titled The Surprising Creativity of Digital Evolution, generally we see these things where the agents in these simulations will find like a loop in the physics of the environment simulation and use it to exploit for its own reward. So see how this seeking agent has learned that it can hop on top of this box to surf into the enclosement of the hiding agents. It was probably not something that the researchers thought of when they were designing the environment. So following the simulations where the seeking agents learn to surf the boxes, the hiding agents then learn to lock all the objects on the field so that they can't exploit the box surfing property. So the training of the hide-and-seek agents is done with this really interesting transformer-like architecture. So you see from the transformer you have, similar to the positional encoding of words in the transformer, they have this positional encoding of the front line of sight of the agents, which is used to mask the attention and then you have the same residual block which skips ahead. So it's sort of like a ResNet skip connection in the transformer architecture, which is used to sense the state in the environment to make the neural network that controls the policy of the agents in this multi-agent hide-and-seek environment. So definitely an interesting extension of the transformer architecture into reinforcement learning agents. So then they talk about miscellaneous things about intrinsic motivation, like searching for novelty and just basing the agents' success off of finding novel patterns to do, like exploring new parts of the environment or just doing interesting new things, but they don't find a great result with that. Then they talk about transfer learning, like going from hiding from the agents into these miscellaneous different tasks that might require like a similar understanding of the world. But generally they find that even though their multi-agent systems perform decently, they don't really outperform the baselines by massive margins in any of these cases. So overall, I think the conclusion of this is that transfer learning and reinforcement learning still has a bit of a way to go. But generally, it's still really interesting. They show some of these surprising behaviors that the agents learn. Most notably is probably box surfing, then the endless running, where if they don't have the explicit bounding coordinates of the map, the agents just like run off into infinity. They have the ramp exploitation, and then they have this case where the seeking agent just runs the ramp against the wall, and then similar to the surprising creativity of digital evolution, it finds this bug in the physics simulator, and it allows it to just bounce up and into the where the hiding agents are. So it's definitely one of the most interesting reinforcement learning environments that we've seen, really cool animations, and a really cool property of having the agents learn how to use tools and then coordinate amongst themselves to complete the task. OpenAI published another really interesting study about fine-tuning the powerful transformer GPT-2 model on human preferences with reinforcement learning. So the GPT-2 model is originally a language model that's trained to predict the next word in a sequence, and in doing so, with this massive transformer architecture, it can learn to complete sentences and paragraphs in really interesting ways. So this study is about fine-tuning and starting to try and get a control over what the language model is outputting, similar to the control language model from Salesforce. So one of the interesting takeaways of this model, of this paper, is that they need much more labels for summarization compared to continuing text in various styles, 60,000 compared to 5,000, and then some really interesting visualizations of how their document summarization agents learn to copy the sentences from the original article in order to score higher, and then showing where in the documents it tends to copy from. So first they show you this visualization to help you get an understanding of what it means to continue the style with a certain token. So similar to like the Salesforce control model, this is how they might fine-tune it with reinforcement learning with positive sentiment, so it would continue it in this way compared to the zero-shot baseline, which is the original output that the GPT-2 model would give you. So most differently is the control model is conditioning the model. It's embedding these positive sentiment or physically descriptive text into the model before it's generating. So compared to this research study, which is fine-tuning the model with reinforcement learning. So also interestingly in this paper is the document summarization, talking about the novelty of the summaries and how when they fine-tune it to achieve better human scorings and then propagate that signal back with reinforcement learning, it becomes less novel. But in the zero shot, which is the original GPT-2 model, the sentences it uses to summarize the text aren't always necessarily true about the document compared to when it's fine-tuned. It's more correct but less novel. So it's definitely interesting, and then this is the visualization of where in the documents the fine-tuned model is copying from. So overall, it's a really interesting description of fine-tuning and getting more control over the transformers to perform useful tasks. Facebook's presented two really interesting advances in self-supervised learning for question answering and for automatic speech recognition learning representations of speech data. So this first paper, Wave to Vec, leverages self-supervised learning. So if you're unfamiliar with self-supervised learning, the high-level idea of it is that you're constructing a supervised learning task, like where you have an explicit 1-0 label or multi-class label, something like that, and you're constructing this from unlabeled data. So the easiest way to understand this is in images. Say you have a data set of images which are unlabeled. You can imagine just rotating them 90, 180, 270 degrees, or not rotating them at all, and then training a classifier to predict the rotation angle. So doing the rotation and constructing the labels in this way doesn't cost you anything. It can be totally automated. There's no humans in the loop that are needed to label data. So that's basically the high-level idea of self-supervised learning, is to do representation learning on different data sets, different data types like images, speech, text, and then do this without having to label data, which is really tedious and labor intensive. So the wave-to-vec system is a similar system to skip-gram word-to-vec in that it predicts the future of the waveform given the current context. So overall, the system is explained well in this animation. Basically, it has the k sound in cat in this waveform, and then it's predicting this subsequent speech token. So basically, you could imagine doing this as you map it to every possible speech frequency that comes next, but this wouldn't work because speech is continuous. So what you need to do is use something called the noise contrastive loss, which is where you're just predicting 1, 0, where 1 is the subsequent sound from the cat in cat, and then miscellaneous randomly sampled noises are used as the 0, or really heavily modified data augmented sounds are following the token. So overall, the system is trained using 1,000 unlabeled samples from the LibreSpeech dataset, which is the dataset it is evaluated on, and then it's fine-tuned with 81 hours of the Wall Street Journal data. So this plot shows how it compares with the previous state-of-the-art, the DeepSpeech 2 model, which is trained with 150 times more labeled data on this LibreSpeech challenge. So overall, it's a really interesting example of self-supervised learning. Lets you use less labeled data, and it can achieve state-of-the-art results. The other post from Facebook, leveraging self-supervised learning in novel ways, is about using AI-generated questions to train NLP question answering systems. So basically, most of these language models are trained using this thing called the close task, or the fill in the blank, masking out the words like word-to-vec. So what you have is things like the Broncos took an early lead in Super Bowl 50 and never trailed. And then you mask out this word and have the model predict this masked out word. So basically what this paper is doing is it's trying to see how you can turn these masked out words into questions. So if you have some mask like the blank took an early lead in Super Bowl 50 and never trailed, you can rephrase this into a question like who took an early lead in Super Bowl 50? And this blank is the same answer to the fill in the blank as it is the question answering potential training sample for the model. So they use this to generate a data set and then evaluate this data set on the popular squad benchmark, and it scores a pretty good score compared to early generations of supervised models. So this is a really interesting technique. Again, this idea of self-supervised learning, where you can make use of massively available unlabeled data to do representation learning and fine-tune models for tasks such as question answering. Facebook was also a heavy participant in this year's Interspeech 2019 conference, which is one of the top conferences on advancing speech technology like speech-to-text, text-to-speech, these automatic speech recognition systems. So in this blog post, they detail two different directions that are important to Facebook, human interaction and voice interfaces, as well as video content understanding. So in the blog post, they also link to several of the different papers they've presented at Interspeech. So you can link to it, you can check it out, and learn more if you're interested in these kinds of things like joint grapheme and phoneme embeddings for contextual end-to-end ASR, sequence-to-sequence speech recognition with time-depth separable convolutions, unsupervised singing voice conversion, wave-to-vec like we just discussed, and then who needs words, lexicon-free speech recognition. So they also talk about this zero-resource speech challenge, which is definitely an interesting thing to think about doing deep learning with less resources. So a lot of really interesting papers to check out if you're interested in speech technology. Facebook's blog post presents their Fashion++ system. So what this is it uses a combination of a variational autoencoder, a classifier to tell if an outfit is fashionable or not, and then a conditional generative adversarial network to render the image with the changes to overall suggest subtle changes to outfits. So it's an interesting example of how AI can be used as digital assistants in miscellaneous contexts. So probably the system is best described in their research paper. You can see how they use the variational autoencoders to compress the texture and shape features of an image into low-dimensional representations, which variational autoencoders are really good at compressing the space into latent features and keeping some structure to the encoded space with way less dimensions than the original space. And then the conditional generative adversarial network is best at re-rendering this into a photorealistic image. So in their paper, they discuss how they also determine what is fashionability. So think about this, what you might, but we're mostly interested here in the deep learning architecture that's used. But basically, they use images of celebrities and then images of pedestrians, where the celebrities are labeled as positive, being fashionable, and then the pedestrians are labeled as not being fashionable. So maybe think about the overall system and its application, what you will. But it's an interesting architecture, and then definitely an interesting thing showing how AI can be used as digital assistants in many, many different contexts. One of the big headlines of this AI weekly update is the concluding of the Interspeech 2019 conference. This is a conference on speech technology using different deep learning or different machine learning miscellaneous techniques for speech technology, text-to-speech, speech-to-text, like ASR, automatic speech recognition systems. So Google in their blog post discussed some of the ways that speech technology is useful for their products, such as things like automatic video captioning, Google Assistant, and then they're discussing some things that they're developing, like their cloud APIs for text-to-speech and speech-to-text, and the Paratron. So you can go through this post and see some of their different papers that they've published in the Interspeech conference, like Shell Fusion end-to-end contextual biasing, or things like spec augment, a data augmentation technique for ASR. So a lot of interesting papers, especially if you're interested in speech technology. There's probably a lot of new things to check out. This episode of AI Weekly Update is lucky to feature one of the monthly newsletter editions of natural language processing news from Sebastian Reuter. You can also check out his writing on Reuter.io. Sebastian Reuter is one of the leading scientists in natural language processing working at DeepMind. So this natural language processing news is headlined by better ways to report experimental results and model errors in NLP, making your BERT model more efficient, particularly around model distillation, some of these semantic evaluation 2020 tasks, and miscellaneous other things curated around deep learning. So the newsletter starts off with this example from Jonathan Fly on fine-tuning the GPT-2 on Harry Potter books and showing what it's able to produce. So seeded with this, through the use of magic, Harry Potter was able to achieve state-of-the-art, and then the bold text is written by the transformer. So you can also check out Hugging Face fine-tuned to GPT-2 on archive papers, which I checked out, and you can give it these sentences from, and then hit tab when you want the GPT-2 to fill in the text, which is highlighted in blue here. Following this is the idea of reporting errors and results in natural language processing, how we can investigate what kinds of errors the NLP systems make on different tasks, and then a more fair way of evaluating different architectures based on the hyperparameter search, because one architecture may appear to be better than another simply because the authors had more computational resources to perfectly fine-tune their hyperparameters to this model. So overall, it's a discussion on making the presentation more fair and considering the hyperparameter tuning in the presentation of the model. So then there's a discussion on ethics in NLP. The recently released control language model by Salesforce is different from fine-tuning on particular data sets because it definitely gives you more control over what the GPT-2 model and these different massive language models are capable of generating. Then there's a discussion on model distillation. Particularly, something I thought was interesting was this paper where you distill the BERT knowledge into a single layer bidirectional LSTM. So overall, there's a lot of interesting ways that model distillation and different things like the adaptive attention span, which we covered a while ago from Facebook, is able to make these transformer models more efficient compared to things like just scaling them up with tons of parameters in the existing architecture. Following this is the Semantic Evaluation 2020. So if you're interested in getting into natural language processing, there are all sorts of different tasks and competitions listed here that you can use to get your foot in the door and get into these competitions. Then there is a link to an interesting roadmap in natural language processing. I thought an infographic, which is really nice just because of how nice the visualization is, even though Sebastian says that certain things are omitted from this infographic. And then Sebastian recommends reading this paper, A Critique of Pure Learning and What Artificial Neural Networks Can Learn from Human Brains, which is shown here. We'll start our coverage of NVIDIA's AI blog with their top 5 AI developer stories of the month. At 5 is the release of the TensorRT 6. What this is a deep learning, inference, and runtime accelerator, allowing you to do things like run inference on the BERT large model in 5.8 milliseconds and on BERT base in 2 milliseconds. And this is also useful for things like object detection, recommendation systems, and image segmentation. So basically what this is when you finish training your model, now you want to use it in production to make predictions. So what this inference accelerator does is it basically makes the stack between your software layer and the hardware layer much better integrated so that you can have a faster inference or prediction with your trained model. F4 is build your own speech recognition model with neural modules. Neural modules is an API released from NVIDIA around this Interspeech 2019 conference for constructing your own speech recognition and natural language processing neural networks. At 3 is how a self-driving car finds parking. The ParkNet deep neural network, you can visualize the output of it here. What it is it is using the convolutional neural networks to identify different parking spots that the self-driving car might be able to park itself in. It's just really cool to see this visualization as well, bridging the gap between our understanding of how self-driving cars might actually interpret the visual world and having these interfaces to see what they see. At 2 on the list is the Google Project Euphonia project. What this is it's a way for the ASR systems to fine-tune themselves to people who have unique dialects, whether it's due to the ALS disease or whether it's due to heavy accents. So overall, it's just a way of making these speech recognition systems more accessible to everyone. At number 1 is the Jetson-based RoboDog Astro, developed at Florida Atlantic University, which is where I am enrolled as a PhD student. The Astro dog is able to respond to speech recognition and to perform different tasks, and it does this by using the NVIDIA Jetson module, which is an embedded system allowing it to have this kind of processing capability on device. NVIDIA's AI blog and podcast detail a startup called Focal Systems, which is looking to bring more computer vision and AI to grocery stores. So the way this system works is it's used in retail evaluation as well as the checkout line of scanning the QR codes and the SKUs to identify different items and look up their prices. So overall, it's a really interesting system of showing how the employees have this task of checking what items are out of stock and how that a computer vision sensor could easily just automate this task of seeing what's in stock in the shelves and what isn't. They also talk about how their system for scanning the items is able to detect amongst 100,000 different SKUs in 0.1 seconds with this 99.9% AUC precision recall metric. So it's definitely a really interesting application of computer vision. They already have their system in 11 major retailers across the world. So it's interesting to think about the future of grocery stores, how computer vision will enable the next generation of automation. NVIDIA also got in on the action of the 2019 Interspeech conference, announcing things like their Jasper model and the NVIDIA Neural Modules Toolkit for building things like speech recognition models. So the NVIDIA Neural Modules framework is basically a system for rendering these acyclic graphs, which are stacks of neural modules that take in input and produce output layers to build these kind of projects. And they're partnering with the Mila lab on their speech brain project with this NVIDIA Neural Modules toolkit. So you can follow their guide on how to use this. They have this Jupyter notebook showing you exactly how to use the neural modules to train a speech recognition model. So following this is the announcement of their Jasper model, just another speech recognizer. So what this is basically like a one-dimensional, it's basically like a ResNet containing one-dimensional convolutions for speech applications. So you see the architecture here, these one-dimensional convolutional batch norm ReLU blocks that are stacked together with the skip connection ahead. So overall, they achieve the an error rate about like sub 3% on this popular LibreSpeech dataset, which is used to evaluate these ASR models. So definitely an interesting model to consider. You can see the overall framework for how these automatic speech recognition models are constructed from a high level, as well as getting into the details of the Jasper, which is the neural module integrated into the overall ASR framework. Interesting news from NVIDIA is the release of their TensorRT 6 high-performance deep learning inference optimizer and runtime accelerator, optimizing for low latency and high throughput inference. So one particular metric that they cite is that they achieve inference on the BERT large model in 5.8 milliseconds and 2 milliseconds on the BERT base model. So overall what this is it's a system for optimizing the integration between the GPU and then the software that runs things like BERT or things like the mask RCNN, faster RCNN, and then recommendation systems as well. So particularly they cite things like 5 times faster inference versus CPU for medical image segmentation because they add these integrations for 3D convolutions. And they discuss miscellaneous different things in which the TensorRT 6 is better suited for the deployment and accelerated inference of these models. NVIDIA will obviously be attending the 2019 GPU Technology Conference, which is going to be hosted in Washington, D.C. from November 4th to 6th. In this blog post, they give you 5 different reasons, amongst many others, to attend the conference and things to be excited about, such as a keynote from Ian Buck, the Vice President of Accelerated Computing at NVIDIA, things like sessions and tutorials on autonomous machines, cybersecurity, and disaster relief, exhibitions of the power of these GPU systems, like using the AI pose estimation to render the guy dancing into this astronaut on Apollo 11, and then things like the assistance of radiology and cinematic rendering with AI. So they have a lot of training sessions in this conference as well. Things like getting started with AI on the Jetson Nano, the embedded system platform, things like deep learning for video analytics, and deep learning for healthcare image analysis. So overall, it's a really interesting conference. There'll definitely be a lot of interesting news following the conference from November 4th to the 6th. Another really interesting post from NVIDIA's blog is about the Machine Hallucination artist exhibition in Manhattan. So they have this overall 5-minute video depicting the show and what it's about. It's a really interesting video. I definitely recommend watching it. Overall, they have cool things in there like walking through the latent space of a StyleGAN on different New York City images. So if you remember what a StyleGAN is, it's a generative adversarial network architecture that has been optimized to have this really smooth latent space interpolation property. So you see how smoothly it transitions from image to image as it's generating them, and this is done through this really clever normalization architecture, also conveniently developed at NVIDIA. So it's a really interesting thing to see things like the latent space of GANs being included in these art exhibitions. This interesting idea of trying to show off how machines can hallucinate, I guess, or how they dream up these different images in their interpretation of the visual world. NVIDIA also posted an article about the need for specialized software stacks to accommodate their supercomputing setup and the GPU technology. So they discussed things like the release of the TensorRT 6 platform, which is able to run the BERT large much faster in 5.8 milliseconds by having this specialized architecture. So they discussed the need for software stacks in vertical domains like robotics, smart cities, autonomous vehicles, healthcare, manufacturing, and 3D rendering, and about how having these specialized software stacks is a necessary component on top of the existing hardware. Forbes posted an article titled the AI 50, a list of 50 really interesting AI startup companies. So I thought it was a really useful list for getting a sense of different applications of AI and deep learning. Definitely interesting not just to focus on the research, but also to see how it's being developed in the industry. So it's a really interesting list. It's ranked a 50-to-1 list based on the financial valuation, things like how much funding they've received. So the list, you definitely read it and you get a great sense of different opportunities you might have if you're looking for a startup job in AI, or investment opportunities if that's something that interests you. So overall, just a great list of different ways that deep learning is being applied. Healthcare is a big theme in this list as well. So definitely things starting like Viz.ai, popular companies like Scale.ai are on this list. Definitely worth checking out. Interesting news from DeepMind is the announcement of a collaboration between DeepMind's health team and Google Health. In this blog post, they quickly discuss some previous research done about things like detecting eye disease from scans, which is something that we've seen in like Kaggle competitions. We've seen the retinal fundus images where you're detecting diabetic retinopathy from these image scans. Also things like cancer radiotherapy treatment, and then the predicting patient deterioration for when they're leaving the hospital. So there's a lot of interesting applications of deep learning in healthcare, doing things like automated medical image diagnosis, and then parsing these electronic health records and miscellaneous things is definitely one of the most interesting applications of AI and deep learning in its current state. The Allen Institute of Artificial Intelligence posted a really interesting app called Supp.ai, which uses natural language processing to parse a massive list of medical papers to find interactions between supplements and drugs. So for example, if you type in the name of a supplement or drug like caffeine, you will see these different interactions with other drugs, with the green indicating that the research papers generally suggest that they have like a positive interaction effect, and then this symbol denoting that they maybe don't go so well together. So it's definitely really interesting, definitely an interesting application of natural language processing to help make sense of the troves and troves of this medical research. One of the most interesting pieces of news this week is the update of Keras 2.3, amongst many miscellaneous changes like deprecating the decay argument, instead asking you to pass in the learning rate scheduler callback, and then miscellaneous things like the class-based losses and the different metrics you can use while training. Probably the most interesting update to Keras 2.3 is that it now supports the TensorFlow 2.0 backend. So they still don't have eager execution for that. You use the TensorFlow.Keras extension like this. So overall, it's really interesting to see the advancement of Keras. Keras is one of my favorite frameworks for deep learning because of just how easy it is to get started with it. Uber posted another series of videos in this series of explaining how AI, deep learning, machine learning is used at Uber. Last week they posted things like explaining their Horovod, Michelangelo, and Pyro frameworks. and we've seen interviews with top research scientists at Uber like Jeff Kloon. And this video is about how deep learning is used to better compute things like the estimated time arrival, match drivers with riders, and do things like developing self-driving cars. Apple was also a big sponsor at the Interspeech 2019 conference with their investment in things like the Siri voice assistant. So in this post from Apple's machine learning journal, they detail a lot of their different accepted papers at the conference. So you can go through this and get a sense of whether this kind of research interests you, relating to speech technology, automatic speech recognition systems, and enhancing speech quality. Floydhub's blog posted an article about the attention mechanism and attention in deep learning. So this article goes over two different kinds of attention and basically the attention that is used in these sequence-to-sequence models. So things like how neural machine translation sequentially encodes the input, and the big problem that motivates attention in the first place is that when you reach this last encoding, if this is a really large input sequence, you've probably lost all the information from the original token. So basically attention is this global view technique of looking at all of the intermediate hidden states. So this article will take you through two different kinds of implementing sequence-to-sequence attention, as well as the actual code for doing it in PyTorch. This week's edition of The Batch from Deeplearning.ai begins with a note from Andrew Ang about the Pi and AI meetup in Malaysia. An interesting thing about seeing AI communities growing around the world. It's really interesting reading The Batch, following along with this. They documented being in Colombia to start it, and now in Malaysia. Really interesting to see the global spread of AI and deep learning and machine learning research. Following this is a discussion of the different agricultural robots using computer vision and robotic dexterity to help overcome labor shortage in U.S. agriculture. So they discuss how generally there are two types of computer vision used in these systems, one to identify the right fruits or vegetables, and the other to guide the robotic dexterity of the picker. Talking about some companies as well, like Vegabot, Agribot, and Abundant Robotics, which is pictured in this diagram. And then discussing how there is this labor shortage in agricultural workers and how the automation is helping to fill this need. Following this is a discussion of Google's Project Euphonia project, which is helping to make ASR speech recognition systems more accessible to people who either have an accent or a speaking impairment. So overall, it's a system that uses fine-tuning with the RNN transducer and listen, attend, and spell model to help it be more adapted to these accented speech and then speech with ALS particularly. Following this is a description of generative models rock. So what this is kind of a trifecta of deep generative models to help produce a song. So what it is it uses the MuseNet to generate the music, the GPT-2 to suggest the lyrics, and then DeepAI's text-to-image API to synthesize the cover art. So it's definitely a very funny combination of these things together, talking about how even these generative models still help the human artist retain some control over the creative process. It isn't like the entire thing is end-to-end automated by these generative models yet. Following this is a discussion on having chatbots talk to other chatbots to automate things like negotiating contracts. So it's definitely interesting to think about how these natural language processing systems can be used to navigate intricate details such as contract negotiation. Following this is a description of working through uncertainty and the importance of using probabilistic frameworks like the Pyro framework from Uber to maybe perform these reinforcement learning tasks because they have a better sense of uncertainty compared to a lot of these deep learning vector output models. So in this quick description, they describe how having a better sense of uncertainty works much better when doing meta-learning and transfer learning for skills between different tasks in this kind of setting. Following this is a discussion on easing cross-border collaboration and how the Partnership on AI has posted this report about how restrictive immigration policies are harming the development of AI research and the transportation of human capital, which is critical to AI. Thanks for watching this AI Weekly Update video. Please subscribe to Henry AI Labs for more deep learning and AI videos.